Okay, this question, you can see we've got 3 redox systems listed in the table, and we've got some cell diagrams there. The 2 cells below were set up in an experiment to compare the standard electropotentials of redox systems C, D, and E. The signs on each electron are shown. The standard cell is set up between redox system D in table 6.1 and a standard hydrogen half cell. The standard cell potential of redox system D is plus 0.34, because therefore we know the standard hydrogen half cell is 0 volts. Okay, we know that. That must mean then that the electropotential of redox system D, because it's connected to a hydrogen half cell, this has also got to be 0.34, the same as the cell potential overall. Okay, the cell delivers a current for length of time. The pH of the solution, the standard hydrogen half cell, decreases. What is the pH of the solution in a standard hydrogen half cell? Now, if you've studied pH in your chemistry course already, this question should be fairly obvious. If you haven't studied pH, then you could find this one a bit confusing. All right, what have we got? The standard hydrogen half cell, well, you will know that in the hydrogen half cell, you've got to have an acidic solution. So you know the pH of the solution has to be low. However, it's a standard hydrogen half cell, so the hydrogen ions will have a concentration of 1 mole per decimeter cubed. So the question is, well, what does that mean in terms of pH? Well, like I say, if you've studied pH, you will know that the pH of a solution is equal to the negative log to the base of 10 of the concentration of hydrogen ions. Okay, so if you haven't studied this yet, this will be unfamiliar to you. If you have, you will know this. And therefore, what you're doing is a negative log of 1. And a negative log of 1 is 0. So the pH in a standard hydrogen half cell is 0, and it can be calculated as 0. So it's easy to be confused on this, because you automatically see, well, it's an acid, therefore it's low, and the most common answer you see there is students put 1, okay, because you expect an acidic solution to have a pH of around 1 or 2, but in this case you're having to physically calculate it using the idea of what pH is. So I recommend, if you haven't done pH yet and you're looking to understand this question a bit more, go and look up this formula and look at pH. Explain in terms of electropotentials and equilibrium why the pH of the solution in the hydrogen half cell decreases as the cell delivers current. Now, once again, reading that question and seeing a pH of 0 can lead you to be a bit confused. It is possible to have pHs less than 0. All right, so whilst the pH of the standard half cell is 0, it is possible for it to decrease further. So we're looking to explain this in terms of electropotentials and equilibrium. So you've got to think about how the half cell will shift. Okay, so if you think about it, your standard hydrogen half cell is 2H plus 2E minus gives you H2. Okay, now because this has got a standard cell potential of 0 volts, and the silver half cell, which we worked at earlier on, is more positive, the silver half cell will reduce, causing the hydrogen half cell to oxidize. Okay, so that must mean equilibrium is shifting to increase the concentration of hydrogen ions, because this equation is moving in that direction. So we can say that equilibrium is shifting to increase the concentration of hydrogen ions. And if that concentration increases, the pH is going to get lower. The more hydrogen ions you have present, the lower the pH is going to be. So 2 marks for this question. It's 1 mark for saying that this half cell, the hydrogen half cell, is more negative than the silver half cell, which I've indicated here by putting the 0.00 volts, and a 2nd mark for stating that the equilibrium will shift to increase the concentration of hydrogen ions.